Profesör Doktor Charles Stiles, scientia et amore vitae konuşmasını yapmak üzere sahneye davet ediyorum. Can I please have you here for your speech?
I can begin speaking while he sets me up here. And at the onset, I would like to thank Dean Turker-Killick and Başlıklı University for giving to me now the best of two worlds. Many years ago, I wanted to become a physician, a medical doctor. But I learned in college at an early time I had two handicaps. One is I'm deathly afraid of needles, and two is I faint dead away at the sight of blood. So I changed my career path. Instead of taking an MD, I took a PhD. I became a scientist. And I've had a satisfactory career, but every once in a while, I wonder about the road not taken. So today, as I said, I have the best of two worlds. I can still earn a living with science, stay away from blood and needles. But after today, I will have more than 100 young doctors with my name on them, and they can deal with the blood and the needles. I will try to keep my remarks brief because I'm standing between all of you and some pleasantries out on the balcony. What I put together in the way of a brief theme for my comments is a symbiotic relationship between medicine and science. Okay? This is my first publication. 3 authors, and it was done with rats. I can do it this way. Yeah. No, that's, 23 authors done with humans. And what this reflects is a sea change in biomedical research. 40 years ago, the papers that scientists like me published in the most prestigious scientific journals, Cell, Nature, or Science, used genetically accessible organisms, the nematode worm, the Drosophila, occasionally the mouse. The Human Genome Project, together with techniques called RNAi and now CRISPRs, has changed everything. It is now possible for scientists like me to go beyond the descriptive level with human cells. For we scientists, the human organism has become the nematode worm of this new millennium. But I am a scientist. I am not a medical doctor. I cannot see patients, work with them. Physicians, such as you, and physician scientists will become the point of the spear for biomedical research in this new millennium. Tomorrow, I will see the members of my medical school class, the Stiles class. I'm going to give them a full scientific talk about this most recent paper of mine. It deals with a problem that all of these cute little children have. Wonderful, attractive-looking children, they all have a brain tumor. Primary cancers of the brain have become the most common cause of cancer-related death in children, and low-grade astrocytomas are the most common brain tumor of childhood. Also a common feature of type 1 neurofibromatosis, which is an even more common genetic syndrome. So on this slide here, I have a few words about low-grade astrocytoma, a sort of good news, bad news prognosis. The good news is that for children with these tumors, if a surgeon like Dr. Killick can get at them and resect the tumor, the prognosis for survival is excellent. The bad news is that these tumors tend to arise in surgically inaccessible regions of the brain. But there's some good news. Unlike adult gliomas and astrocytomas, the low-grade astrocytomas of children are typically responsive to radiation and chemotherapy. But again, there's bad news. The tumors will shrink following chemotherapy, but very typically in 2 or 3 years they come back. Interestingly enough, when they recur, the pediatric cancers will often respond to an identical course of chemotherapy. This is quite unlike adult cancers. So the disease becomes, in effect, a relapsing remitting disease. For reasons we don't quite understand, if we can keep the children alive into their early 20s, the tumors will become dormant, and the children will then go on and live. But by that time, although we've won all the battles, we have really lost the war. You've been treating growing children for decades with genotoxic drugs, and their quality of life will become very poor. The bottom line is that this disease needs a new kind of medicine. You want to kill cancer cells, we've known how to do that for decades, radiation, genotoxic drugs. But this disease needs targeted therapeutics, smart drugs. And a clinician, whose name you'll see in a few minutes, came to me, a scientist, and said, Chuck, we need your help. So we found, as I said, a mutation. The human organism is a nematode worm of the new millennium. The forward genetic screen is ongoing every day. The mutants are walking into our clinic, your clinic. And it turns out that there is an activating mutation in an oncogene called BRAF, which is found in 70% of low-grade astrocytomas. And this is a druggable event. BRAF is one of the few oncogenes we can make small molecule inhibitors of it. But the challenges are that the vast majority of these mutants are of a type that's intrinsically unresponsive to currently approved RAF inhibitors. And the second challenge is, of course, the well-known blood-brain barrier. So that's what this most recent paper of mine is all about, a brain-penetrant RAF dimer antagonist for the non-canonical RAF oncoproteins of pediatric low-grade astrocytomas. A big word with 23 co-authors. And the point I wanted to make here for all of you today is that this is a perfect vehicle for illustrating that symbiotic relationship that I discussed between basic scientists and clinicians. This work involved, at the onset, some PhD level synthetic organic chemists, Nathaniel Gray and Sarah Burlage. We have a program in low-grade astrocytoma that spans the waterfront from the hard sciences, genomics, proteomics, chemistry, to cell biology, developmental biology. My own laboratory, two of my colleagues are brain development experts. We put together model lines for screening drugs. We then took these drugs to the human organism. This required us to connect with a brain surgeon, Lily Gumnarova, and a neuropathologist, Keith Ligon. And we were successful, as the students will hear tomorrow. We were able to develop a drug that penetrates the brain, targets the genetic lesion in these tumors, and hand this drug off, finally, to Dr. Kieran, who is a neuro-oncologist that came to all of us. So the conclusion of all this is there's a symbiotic relationship between science and medicine. You need us. You need PhD scientists to do your job, and we need you to do our job. The most interesting experiments to do now are conducted on human cells. The second line is you do not need to be in the trenches with us basic scientists. Some of you will go on to do research yourself. You'll go into the laboratories. A few of you might even get a PhD, become an MD, PhD. This is wonderful if you want to do it, but you don't need to do it. Working back here, this brain surgeon, Lily Gumnarova, she is a full-time clinician, does nothing but cut brain tumors out of kids, but she is friendly, she is interactive, she appreciates science, and she works with us day in, day out. All you need to do is be receptive and interactive, and you can have a useful life as a full-time clinician. If you do decide to do some science, be prepared to commit the time. We are not cutting up frogs anymore in basic science research, biomedical research. The days where you can publish a top-tier paper in a prestigious journal with 3 authors, those days are gone. Biomedical research has traveled down the road traveled hitherto by chemistry and high-energy physics. The most important papers require an interdisciplinary team, and it requires a lot of time. Your own dean, Dr. Killick, came to my laboratory, probably more years ago than he wants to remember, and together he and I published, he mostly published, the most important paper that has ever had my name on it. This was a paper that really rescued a drug called Gleevec. But your dean came to Boston thinking, I think he was going to spend maybe a 6-month period of time, and I think when the smoke cleared, he'd been there for 2 years before that paper was finally done. Okay, that's the kind of time it takes. That's a minimum right now. These days it takes minimum 2 years, more often 3 to 5 to get something done. You need to be prepared to spend that kind of time, okay? So I conclude my remarks with the best wishes to all of you young doctors in this class for the road ahead, and special wishes for the Stiles class. I've got my eye on you. All right. Thanks.